Hello, everyone. Welcome to today's webinar, Enabling Secure, Scalable, and Consistent Application Delivery in a Multi-Cloud World. Before we start, a few housekeeping items. Before you start this presentation, we want to point out that you can use the Q&A window to enter your questions during the presentation, and we will answer them at the end during our Q&A period. This webinar is also being recorded and will be available online on demand, and we will send out the link to the presentation and recording afterwards. If you find this content useful, please feel free to share this link with your colleagues. So now let's get started. My name is Frank Yu. I'm the Senior Product Marketing Manager for VMware, and we have a great guest with us, or speaker with us today, Vijendra Singh. Vijay, can you introduce yourselves?
Yeah, hello everyone. So my name is Vijendra Singh and I'm part of VMware team and I'm taking care of technical product management as part of VMware team.
That's awesome. Thank you, Vijay. So let's start talking about this topic. Enabling secure, scalable, and consistent application delivery in a multi-cloud is a great conversation for us to have because we're all talking about multi-cloud, hybrid clouds, going into these different environments and try to bring them together to provide all these things that we want from cloud benefits, this scalability, this resiliency, elasticity, and it's challenging for us. So we're going to talk today on how we can do it, how we can integrate with the various pieces, and we're going to talk specifically in today's presentation about Oracle Cloud and the VMware solution and things that we can do, as well as how that translates to other clouds also. So here's the agenda that we have for today. Hybrid cloud requirements. What do we need in a hybrid cloud? What do we want in a hybrid cloud? What are we looking to achieve in these hybrid cloud environments, in these multi-cloud scenarios with private cloud, et cetera, public cloud? And then what I want to do is then step into VMware NSX Advanced Load Balancer, because VMware NSX Advanced Load Balancer is, for me, and I'm a little biased, a central point to bring all these pieces together when we talk about hybrid cloud and these use cases and these environments, because it is taking the application and bridging the infrastructure to provide a unified structure for you to manage that application. So I'm kind of giving a little bit away right now, but it's really important for us when we talk about this. Excuse me. And next, I want to talk about integration with Oracle Cloud. So how does NSX Advanced Load Balancer integrate with Oracle Cloud? What are the benefits? How does it tie together? And then lastly, we're going to talk about, or not quite last, but we're going to talk about integration with Oracle Cloud with the VMware solution. So not just NSX Advanced Load Balancer into Oracle Cloud, but there's a lot of other VMware components that we can talk about and tying it all together. And there's some really cool things that we want to mention in terms of how this all comes together and provides a really nice hybrid cloud solution for your environments. And then Vijendra is going to provide this really cool demo to show how this all comes together, how it all works, and how you can configure it, and how to make it easy. Excuse me. And make it easy for you, not just in terms of deployment, but operationally as well. And then again, at the end, we're going to have a Q&A where you're going to hopefully pose some really good questions for us, and we're more than happy to answer them. And of course, as people always like to say, there's no such thing as a bad question. So please drop your comments in, drop your questions in, and we'll be happy to answer them at the end of this conversation. So thank you, Vijendra. And so why are we talking about public cloud, hybrid cloud? Why are we doing all these things? And you can see from the title, we are addressing customer needs from modernization to data center extension. And yeah, that's a mouthful. But what we're really trying to do is we're trying to give ourselves a flexibility of these cloud infrastructures. We want to make it fast. We want to make it cost effective. We want to take advantage of these services and capabilities. And when I think of cloud, for example, when I think of cloud at the core, I'm thinking about three key things that I want to achieve from it. One is elasticity, that flexibility, that scalability to breathe. So when you look at these use cases on this slide, and I'm not going to read out every single use case, there's so many there, and there's a lot more that we can think of. The scalability, these elasticities, flexing up and down. You can see in the center there, data center expansion, seasonal spikes, regional expansion, unplanned projects, and then even to the right, desktop bursting, for example. That elasticity, like my best example that I like to talk about is when we talk about holiday periods. In the US, we have something after our holiday Thanksgiving in November, holiday shopping season, we have something called Black Friday and Cyber Monday, where the online sales spike tremendously, many fold, even tenfold or more in terms of amount of traffic. How do you scale for that spike and then not have to worry about it and have all this unused resources allocated for the rest of the year? And that's elasticity. And then we have agility. How do we change things quickly and easily in our application environment? And cloud has that flexibility to give us that. So when we talk about things like application modernization, and we can see their existing app transformation, next generation app development. And as we move forward, we see things like data center right sizing, consolidation. We want to be able to change things quickly and easily and kind of spin on a dime, to use that saying, where we can move things in a very flexible manner. And the last thing, or one of the last things I like to talk about when I talk about this concept of hybrid cloud, why am I doing this? Is this concept of resiliency. I want to make sure that my stuff is alive and it stays alive. I want this concept of, in the legacy world, we used to call it disaster, and we still do call it disaster recovery, this concept of DR. My primary data center fails, I need to flip over. I want the ability to set up so that I can move things around applications and have that fault tolerance for my applications. And again, we can see examples where we have implement new DR plan, disaster recovery in the cloud. The whole right side, that whole right column talks about this concept of disaster recovery fault tolerance. And then we even have things like that can be introduced and related, like data center site retirement under the second bullet. There were data center footprint reduction or exit. That can be related to disaster recovery also, because we're talking about flipping the switch from one site to another site, which is the concept of disaster recovery. We can see desktop virtualization in the cloud, desktop disaster recovery protection. So all these things, these three key things I talked about, spread out into these multitudes of use cases. And again, this slide gives us a nice view of different ways we can look at this. But there's so much we can do that we want to take advantage of in the cloud. And the question is, how do we do that? And how does that technology enable us to take advantage of these features and these benefits that we want from the cloud? Because the cloud doesn't do it just inherently. You can't just say, I'm in the cloud and therefore I now have all these benefits. Boom, I'm done. That's not the way it works. We need to do things to drive and put these features together. And that's what we're going to talk about today. So let's move to the next slide. So when we talk about the VMware NSX Event List Balancer, I mentioned, and again, kind of giving away a little bit of the story, is that it's a key linchpin because it is, the load balancer is the bottleneck point for application access in your data center environment. So it is providing that local traffic management. I'm going down the left-hand side there. Local traffic management is that server load balancing, that traditional reverse proxy. I have pools of servers and it's managing it. And then I have the global traffic management, which is the DNS manipulation. That is a site, multi-site availability. So that disaster recovery, that active or active standby capability. We have security, the web application firewall and application security, which is, hey, if we're going to be in front of the applications, if we're looking at content anyways for load balancing purposes, absolutely let's apply security. Container ingress services. So this is an interesting one because now we're talking about not just your legacy, I say legacy, these virtual machines, but we also have these modern apps. We're using microservices and containers. And load balancer now can provide ingress services, which is really useful for that Kubernetes orchestration infrastructure for managing these microservices, because it becomes very intensive to deal with all the different components. Analytics of observability. You have to be able to see to be able to make changes. You have to be able to observe. You have to collect the data to be able to understand what's going on in your network and say, I need to change this, or even automate those changes. And of course, DNS and IPAM, IP address management, IPAM, to be able to bring it all together. So there's a lot of cool things that load balancer does. And we do it in a multi-cloud environment. So we want to support, at least from a VMware perspective, and of course, I'm pitching where I work, but I really do believe this story is that you need to work in all the clouds. So you can see here on this diagram, we have AWS, we have Google Cloud, we have Azure, of course we have Oracle Cloud, because we're talking a lot about Oracle Cloud today. And we support all these open source and third-party pieces like Kubernetes and OpenShift and OpenStack, and you can see this again, and that's not the full list. That's just what we put in this little slide, but there's a lot more. And of course, VMware being the family of products that we are and solutions that we are, we have lots of other components we integrate with internally. So VMware is not just, of course, VMware NSX Advanced Load Balancer, but you have the NSX networking platform. You have VCF, Virtual Cloud Foundation. You have Horizon, which is your virtualized desktop environment. You have vSphere, you have Tanzu, you have ARIA, which is now VRO and VRA, the vRealize orchestration and automation. There's so many pieces, and we, of course, tie into and hook into these. And for VMware, our real goal is to deliver any app on any cloud with one platform. We want to kind of separate or hide that infrastructure layer and say, it doesn't matter what your infrastructure is, we're going to give you a single platform so that you can have any application in any cloud, but that you only have to manage it from one platform. So that's kind of the tagline that I want to partially have you take away from this session. So there's a lot of cool things. So let's keep on moving on here. We talked about the NSX load balancer. Why is it really cool? Why do I like it? Why does it excite me as a technologist? And one of the main reasons is because the way we architected the technology. So you can see control plane, data plane. And we really separate the control plane, the data plane. So you think control plane, data plane, you think software defined. Yeah, it's kind of like software defined. Control plane, where you manage and control everything. You configure, you design things, you set up your load balancing instances and all the other pieces and define your applications. And then the control plane determines this is where I need to do the load balancing function, the data plane, the actual load balancing itself. And it tells the different pieces, hey, bring up an instance of the data plane of what we call the service engine here, the service engine there in the data plane. So it does that automatically. You don't have to configure, you don't have to have separate load balancers that you deal with all over the place. So, and it works within bare metal, virtualized containers, public cloud, on-prem. Again, we separate and distinguish that infrastructure so that you don't have to worry about it. So we have that central orchestration, we have the elasticity. So when you need to spin up more instances of the service engines, it can actually be done automatically through that central orchestration elasticity. It can say, wow, I have X amount of resources that I have, and I'm seeing utilization increasing a certain amount. I need to change that. And so I provide that elasticity. I can provide the resilience, so that fault tolerance. So when I notice that a system fails, you just saw in the diagram, something fails, we see that through that analytics. We get the information to say, okay, something failed. I need to flip things over. I need to change resources. I need to add resources somewhere else to automatically do things. And tying these things together in terms of the central orchestration, elasticity, resilience, and these analytics into the automation platform really gives you this really flexible and scalable load balancing infrastructure, which is really cool. And then tying that into what we call something called Pulse. Pulse is your external intelligence service. So when there are new security threats, when there are new updates, when there are other things changing, for example, when we talk about security, OWASP top 10, cross-site scripting, SQL injection, those types of attacks. When there's something new that comes out, for example, a couple years ago now, Log4j was the hot thing. And Pulse will send you an update saying, here is Log4j, and here's the threat, here's how we detect it, and we can mitigate it. So you don't have to worry about that, give you peace of mind. So that's really important service, is that online interactive service through the Pulse service. So now when we talk about these product capabilities, let's look at it from a bigger picture. We have the software deployment platform. We talk about these functions, the orchestration, the elasticity, resilience, the automation, all these things that we want to take advantage of in the cloud infrastructure. This is what we want. And then we have these application services, the actual features and functions, the local traffic management, the server load balancing, the global traffic management, DNS manipulation, application security, WAF, API security, container ingress services for your modern applications. And we're going to now take those two pieces, the top and bottom section, and tie that together with all the analytics and observability, the data that we're collecting. We're bringing that together so that we can say, wow, this is really cool. I can see what is happening. And because I can see the traffic that is happening, I can bring it together and say, we need to do X, or I need to automate and create a script or a tool that does Y because of this situation. So that scalability, the resiliency, the agility that I talked about at the very beginning, those key things I want from the cloud infrastructure, we can tie that into this tool to make it very beneficial and work with you. So let's move on. One of the things I do want to touch on too is security, because security is such a big thing. And we have a web application firewall built into it. And this web application firewall is very robust and is really cool and does things where you can do things like API security. You can do things like OWASP top 10 protection. So you can provide compliance, support your compliance requirements. Whether it's your compliance could be various things like PCI DSS, your financial information. There's multiple levels of compliance that you might have to deal with. It could be compliance dealing with GDPR, for example, if you're European. Or in the US, we have things like HIPAA and FERPA and other types of compliance type. You can apply these policies into your security as well as protecting against all the attacks. And you can see here that we do multiple levels of security, because security should always be a multi-layered approach. Wherever you can, whenever you can, at all levels. So you can see we go from the bottom to the top. We're going from the layer 3, layer 4 firewall, DDoS mitigation, so SYN flood attacks, TCP flood attacks. We do encryption and decryption. So we do the SSL TLS termination so that we can provide proper encryption support. User authentication, layer 7 firewall. So layer 7 firewall, and then again, application rate limiting. And the web application firewall, we can do the full piece. And this again ties into the visibility and insights. So these analytics and observability that I talk about ties into the security as well. And the last piece of this is that Pulse service. The service where you provide the IP reputation signatures, the real-time threats, because we need to have real-time threat information because these threats are constantly changing. So security becomes a huge piece of these ingress and the security of the load balancing model, that it really becomes an integrated piece of the security of the load balancing model that you really need to pay attention to. So let's move on. And of course here, I think you've heard me talk about this a lot. And again, I can talk about it for hours, and there's really cool things. I like chatting and you can see discussing about this. But here, I really want to pass it to Vijendra, because he's going to be talking about the NSX Advanced Load Balancer integration into this cloud environment. And really and truly what we're talking about specifically is Oracle Cloud VMware Solution, OCVS, but this does translate into all these different environments that we're talking about. So Vijendra, please take it away.
Sure. Thanks, Frank, for such a detailed introduction to NSX ALB. And as part of the next few slides, I'm going to cover what exactly OCVS is and what problems it is solving and how NSX ALB integrates into OCVS solution. Post that, I'm going to talk about few use cases that Frank highlighted while he was introducing NSX ALB, and post the use cases, I'm going to showcase a demo where we'll go through few workflows and how this hybrid environment looks like and how NSX ALB gives a experience which is not dependent on clouds you are working with. So that's the agenda for next few slides. So moving to the next slide, basically this solution called Oracle Cloud VMware solution, it came in existence in 2018 timeframe when VMware and Oracle partnered to come up with this solution. And what exactly this solution is, this is a customer managed infrastructure as a service solution. And what it provides is it provides a stack that runs on Oracle Cloud infrastructure on a particular region, and customer gets a bare metal where they can run their VMware stack. And while they have this VMware stack, they can actually talk to other Oracle Cloud native services and can integrate with them and can in turn talk to the local software-defined data center they are running. And how it happens is basically a bare metal it follows a complete bare metal architecture where customers can run their VMware as SDDC, and they have vSphere, they have NSX running, they have HCX running, and so they have this virtual cloud network which can talk to the on-premise data centers and which can talk to the cloud native services. So why this came into existence is one big reason was security. So security has always been a top priority, and customer want a secure environment. So what OCVS does is it provides a entirely isolated bare metal servers to the customers, and no Oracle or no other customers can have a view of these the servers running OCVS solution. So that's a secure environment, and customer always wanted to manage their VMware estate by upgrading their solutions whenever they need, and they always wanted a root access or full access. So OCVS provides a full access into the VMware stack, and customer prefer these solutions because they have a predictability of the environment. They know what is coming next and how much they can expand, and when they need a new data center, those sort of questions could be answered. And then another use case is basically migrating their workloads from the on-premise data center to the cloud on the OCVS solution, and that works seamlessly and it happens very smoothly. So that's what about this Oracle Cloud VMware solution. Now, this is a high-level overview of how NSX ALB integrates into the Oracle Cloud VMware solution. So in this diagram, you can see that blue box is basically Oracle Cloud VMware solution, SDDC running, and we see that this is managed by NSX. So NSX overlay basically manages the traffic between the virtual machines running inside the Oracle Cloud VMware solution SDDC. And this VCN is basically virtual cloud network routing, and it acts as a gateway for various services such as SDDC networking, and through VCN it can talk to other native OCI services. And then on top we have this dynamic routing gateway, which is basically a virtual router, and this gateway particularly helps to connect to other VCNs, and via this you can connect to internet and you can run this IPsec tunnels, and you can have multiple connection on this particular virtual network. So this is the benefit of running OCVS, that via VCN you can talk to other OCI services, you can connect to other VCN running, another SDDC running, you can connect to the on-premise software-defined data centers. And coming to the AVI part, the icon you see here is basically the control plane of AVI. As Frank was mentioning, we have a separate control plane and data plane. So as day zero operations, we bring up controller, and we do something called creating a cloud connector, which tells about which infra it is running on. And once controller has an insight into which infra it is running, it can basically manage that infra, and OCVS provides a full access into the infrastructure, and it can spin up the data plane as and when it is needed. And with enterprise edition of AVI, it comes with full featured load balancing features, which Frank was talking about, and of course global server load balancing, security, WAF, analytics. So these are the things that you get with NSX ALB enterprise edition. Coming to the use cases, it could be used as a standalone data center running load balancing and running a lot of application being load balanced by NSX ALB, or this could be a SDDC, which is created for disaster recovery or DR setup, where it can be a active or the standby site. And as of now, we have seen like data center expansion where people have their on-premise data center running and they want to expand data. And other thing is the burst capacity. So whenever there are Black Friday sale or any sort of traffic, when it goes up, then the on-premise cloud needs to burst to the public cloud. So there could be instance that could be brought up using our automation, and you can have your applications running onto the OCVS solution or any other cloud solution. So these are the primary use cases that we see with this. Now coming one step deeper into the solution. So here in this diagram, the part that you see on the right hand side is basically this solution where we are running the actual workload machines, workload VMs, and on the left hand side, these are the control plane machines. So here you see on a OCVS data center, we have a vCenter running and we have an NSX manager running. So our control plane node controller is first thing that you do when you have to bring up NSX ALB solution. Once you have the controller up, what we can do, we provide credentials to these controllers of NSX manager and vCenter manager. So once the credentials are there and controller has access, read and write access to NSX and vCenter, it will give a green signal that, okay, I am ready to take any instructions that you want to give me. So post that, what it can do, it can actually manage the life cycle of these load balancer instances that you see here. It can actually spin up virtual machines that will act as a load balancer. It can read into what overlay network are there and what transport nodes are configured on NSX, and it have a view of the segments that it has, and it can use those segments. It can bring up virtual machines on vCenter, and those virtual machines will actually act as load balancer. We are going to see all of these as part of our demo. And for here, I want to talk a little bit about elasticity. So whenever you know that load balancing is being done by this load balancer, which is called service engine, and we create virtual services that will actually load balance traffic to the actual application running on this SDDC. And when we see these service engines reaching its limit, we can anytime just scale it to multiple service engines. So we will just multiply the capacity and there will be new service engines coming up and taking the incoming client connections because the first one has reached its limit. And all of these could be done either manual, or you can configure triggers, which will actually be responsible for giving command to the controller that I need another instance of service engine and I want few more clients that I need to load balance. So that's about the elasticity that we have, and we can configure IPAM, DNS, and we have integration with third-party IPAMs as well. So that's what it does. And while I spoke about the elasticity, you need not to worry about any of the pieces about bringing up these service engines. You just have to say that I need another instance of this service engine. I need to load balance this particular virtual service on another service engine, and it happens automatically. Controller will give instructions to vCenter, NSX, and they will do what is needful. So that's the power of automation. Coming to the next slide, here you see how this happens. So in the center, we have this controller, and on the left-hand side, we have vCenter. So on the controller, we have to tell what type of infra we are going to use. So there could be possibilities that we want to create the vCenter cloud, where we only want to deal with vCenter and we do not want NSX manager, but it can still use networks provided by NSX manager. And the second mode is NSX cloud, where we give credentials to NSX as well as vCenter, and it can read into the NSX managed networks. And at vCenter, it knows how many hosts are running and what capacity they are running with and what port groups it has. So based on that, it can actually deploy service engines on demand, and clients just have to simply tell, these are the virtual services, these are the virtual services I need for load balancing the applications that they are running, and it automatically spins up these service engines. And you have configuration where you can tell what host to use and what things you need to do for bringing up these service engine, what size of service engine should come up. So all these are automated. Now coming towards the the NSX load balancer use cases and benefits. So first on this slide, as as Frank was talking about the hybrid cloud environment. So right now we have seen cases where companies in past few years have struggled, where the data center failed, and there were downtime because of these data center failure. So what they can have, or what most companies nowadays have, is they have multiple data centers running for themselves, and they have multiple instances of application running on the private cloud, public cloud, and solutions such as Oracle, VMware solution, SDDC running on OCI infrastructure. And what you can do is you can create an application and you can run that application on on-premise data center. Same application you can run on an OCVS data center, and another instance of this application can run on public cloud. And all of these could be load balanced via DNS-based load balancing, which we call GSLB, Global Server Load Balancing. So GSLB is basically a wrapper that is around these data centers or these clusters that we see here. And what GSLB does is it basically routes the traffic to a particular DNS-VS, which may or may not run on each site. And then based on the algorithm, it figures out which IP it should resolve this DNS query to. So we have this geo-based load balancing where it will figure out where this client is coming from. So there could be instance of this on-premise instance could be running in US, San Francisco. This OCVS instance can be in Japan region, and this public cloud instance can be in India. So while we have all these running in different geolocation, and if a client requests from any part of the world, then we figure out, okay, this is based on this particular geolocation, and we should be load balancing this to a particular app running on particular data center. So we will resolve that particular query to a web IP which is running on, let's say if the client came from India, we will resolve it to this public cloud instance which is running in India. So that's how the hybrid cloud solution work, and we can play around with ratio on the GSLB services and how you should be load balancing in different algorithms. So these are the primary use cases that we have. And apart from that, I think cloud bursting is a case whenever the limit reaches, we can just spin up a new data center and we can update GSLB service that there's a new instance that came in, and we can just make sure that DNS requests are basically resolving to the new webs. So moving on to the next use case. So this is a use case that primarily people who have seen the shift from on-premise to cloud, and they want to expand capacities, or they want to move their data center completely onto a solution such as OCVS. So this site that you see in this picture is basically an on-premise data center running few application or DNSVS, a service engine is running and it is being load balanced. So the sales.vmware.com is being load balanced by this particular load balancer, this particular service engine. Now what you want to do is you want to just move to a new service called OCVS, which is Oracle Cloud VMware Solution. So what you do is you create a OCVS data center SDDC, and this would be your final site where you want to move. So what you will do, you will just create a replica of an application, and then you will be creating a cluster there, and on top of it you will have GSLB running, and you can create GSLB site onto your cluster and tell them there is a new cluster that came in, and you can slightly move your workloads to this new cluster, and you keep on adding your virtual services which are being load balanced by this GSLB. And finally, when you have this and when you have everything moved to the new OCVS SDDC, you just cut off that GSLB load balancing algorithm, and you just tell, okay, now all the DNS queries should go to the new data center. So that's a lift and shift use case. Now coming to the primary case, which is disaster recovery, which is the main concern for people who have seen downtime in their career or whenever their website is down, because of course, whenever we talk about the disaster, it definitely means a lot of financial loss and loss of reputation for your company. We have seen a lot of big companies failing to keep their websites up to date or keep their services up to date. So what happens is you have this particular app running on this site one, and this is being load balanced by service engine one, and it has a DNSVS running which resolves the DNS query to this particular web. And what happens if it is down? So in case when there are no there is no standby site, it will basically, you will start seeing service not available response to your clients, and it will be a very bad user experience. So in such cases, what you do, you create standby sites, and you keep those standby sites ready. And as soon as you have a GSLB service running, and as soon as you realize that, okay, the VSs are not up. So in GSLB service, we can actually create health monitors, which can monitor the health of a particular GS, and it knows that this particular site is down, and it will start sending the request to this new site, which is standby site. So this was the use case that that will help recover from disaster, and this will not let disaster happen. And our GSLB health monitoring is pretty well to figure out that there are going to be, the health is going bad and there could be a outage, and as soon as we figure out an outage, we will just load balance to a new site which is standby. Now, these were the few scenarios that I have covered, and I'm going to showcase demo, and I'll just show how it looks like when you have multiple clusters running, when you have virtual services, and how analytics help you to debug your scenarios. A little bit on the licensing side before I move into the demo. So basically, NSX LB is being licensed based on the actual service unit that you use. So controller we have spoken about are completely free, and there are no licenses for controller, but the service engines that we run, actual load balancer, are being charged, and they are being charged for based on the service unit. Based on their capacity, we'll figure out how many service cores or the vCPUs are needed for particular load, and based on that we calculate how many service units a customer is going to need, and we charge based on that. And there are a lot of term and variable SKUs are available. And for the OCVS, there are no support for basic edition, and it's only enterprise edition, and I've spoken about the benefits of enterprise edition in the previous slides. Now I will move on to demo, and I'll just showcase how the controller cluster looks like, and day zero configurations and workflow of bringing up a virtual service. And post that, I'll just showcase how analytics can help you reduce the time you take to actually figure out the problem with your servers or whatever issues that you may have in your data center. And post that, I'll just show this hybrid cloud workflow, how it looks like on a particular cluster. Now, yes. So when you enter into a controller cluster, that's how it looks like. And first view that you have is this application view. And as I said, on the day zero, you bring up a controller, and controller is nothing but a cluster of 3 controller VMs. So you use controller OVA or controller VHD in case of Azure, and in whatever environment you're running on. So this cluster is basically a 3-node cluster, and the 3-node cluster is running this UI that you see. And first thing that we need to do is we need to go to this infrastructure tab, and we have a concept called cloud. So this is the place when I said controller needs to know which infrastructure it needs to run. So on top level, we have this create cloud, and it gives to you different environments, which is NSXT, vCenter, AWS, Linux Server Cloud, Azure Cloud, and Google Cloud Platform. So whatever environment you're running, it could be subset of one of these parameters. For example, in OCI, you always create a Linux Server Cloud, and in case of OCVS, you do NSXT Cloud. So here I'll just showcase day zero configuration for cloud. Let's say we have to first time create a cloud. So we'll go to this tab, and you have to tell what is your cloud name, and you have to give the credentials for your vCenter. So as soon as you give this credentials, it will basically create a cloud connector user. And when you say save, what it will do some API request to the vCenter, and it will try to figure out the configuration on the vCenter. So it may be running a lot of nodes and port groups. It will know everything that these are the servers, ESX Azure servers, where I can bring up my service engines, and you can configure your IPM, or you can use third-party IPM such as info blocks, and you can create your DNS resolvers, etc. And when you do save, it will basically save the configuration, and it will just create a cloud for you. Right now, this is a cloud already created, and post this, if we see this green, then it means that we have a cloud ready, which means you can bring up the instances for load balancer. Now, the next thing that we have to do is create virtual service. And on top level, you see this, there are a lot of tenants. As I mean, all the access are basically based on the role-based access control, and you can have multiple tenants. You can have admins which manages the infrastructure, and you can have tenants which do not have access into the rights to create the infrastructure, but they can use infrastructure to deploy their virtual services and apps. So here you see different tenants. I will just move to a demo tenant, and while I'm here, I'll just try to create a virtual service. So first thing that you have to do is you have to choose a cloud, which particular cloud you want to create a virtual service. And if you say next, you will get into this screen where you have to tell that which VS you want to run, which VS you want, and you have to create a VS Web. So VS Web is basically an object that you create, which is responsible for attracting the traffic towards the infrastructure that we are running on. So here we have to give web, and for web, it has access to the vCenter. It knows what networks is running on this vCenter, and you can say private IP auto locate, which will use DHCP, or you can give static if you want to. And we have a lot of networks that we can see, and then there are like subnets that we have to choose for creating a particular virtual service. If you say save, okay, so we have added this auto allocate. Right, so I think I have to, right, or you can just choose this v4, and you choose this. So I think there are some issues with this, and probably I'll just showcase how exactly a particular demo VS looks like. So this is our VS which is running. So I'll just showcase an object that is pre-created here. So when I say create a virtual service, it will just allocate. So probably a static configuration is needed, and static configuration here will showcase which IP address you want. And this is the IP where it will be listening the traffic. The web will be listening on this particular thing. And you can mention what ports you need. So in this case, it is a SSL VS, and you have to mention the layer 4 profile, which is TCP proxy here, and an application profile. So application profile is basically layer 7 profile where you can choose between these applications. And post that, you have to configure your backend. So this is the backend configuration. So if you see this configuration, you have to tell what backend you want to use and what load balancing algorithm is needed here. And these are the actual servers which we will need for load balancing our traffic. So web will attract traffic, and on the backend, it will be load balanced here. And you can actually configure health monitors. So in this particular case, we know that HTTP backends are running. So we configure this system HTTP health mon, and there could be different type of health mons that we can configure, which will keep sending the health monitor request to the backend pools, and it will know that when a pool is going down. And next is we can configure what certificates you want to use for your SSL profile. And then if you click on save, or yeah, here are the policies that you will see. So when you click next, you will see these policies which we can create: HTTP security, HTTP request response. So what happens is, based on like request, you can take some actions, and you can redirect the traffic to a particular pool, particular server. Those sort of policies could be placed here. And there are data scripts that are Lua based, and based on these data scripts, you can configure certain actions that you want to take. So these are the replacement of different policies, different rules on a particular VS could be done via the data scripts. So data scripts are like very powerful tool that we use. And coming to the AVI demo, we have a lot of analytics and logs available on these particular demo sites. So I'll just showcase some cases where the analytics help. So if we see these particular cases, these are like significant logs. So we have this logging enabled. So significant logs means there are certain things that are wrong with a particular request. And if we expand on this data, we will see that there is a reason for significance. So in this view, we can actually see where exactly this traffic is coming from, and the location is US. This is a client IP, what SSL version it is using, which is the browser it is coming from, what's operating system. And here, if you want to see why it is significant, it says like high app response time. So this is the reason. And when we have to debug why exactly this is wrong and why the app response time is high, you can actually just hover over this right-hand side analytics, and we can figure out that these are the client-side analytics, and we can see what are the locations that it is coming from. And you will see like US is this much, and these are the end-to-end timings that we see from the client. So you see, these are the time range, and I can just figure out a few cases where it is taking too much time range for this. So I'll choose here, and the search bar here is basically a pretty much Google-like experience when you have to search something. So I'll just search request when this total time was greater than 600, and then you go here and you see what load balancer analytics and what server it could be. So we'll go here and we'll see out of those four servers, 99.51% of these logs that we have filtered are because of this. So by looking at this, we can figure out that this is the culprit server, which is basically making these app response time high. So whenever you have an event, you know where to go, how to look for. So analytics help you to debug these sort of issues pretty well, and you can just figure out request analysis, how many requests are coming from HTTP 2 versus HTTP 1, and those sort of analytics we'll see. So this is how like analytics is useful when we have to debug something. And coming to the next part, which is the GSLB that I was talking about. So I spoke about like a hybrid solution where you have multiple clouds, and these are the sites that are running. So if I go to C3, so this is our GSLB leader. If I go to this side, I have to go to infrastructure, and you will see site configuration. So right now we are running this AVI demo on 5 active sites, and you will see these sites are basically the San Francisco, London, Tokyo, Sao Paulo, and Brisbane. So we are running our app called c1.avidemo.vmware.com on these sites, and this is the GSLB use case. So same application running on 5 sites, and we have all these GS services running. That's where we configure, and we can actually add a new site here. We have to tell what name and what is the username and password for that controller cluster that we brought up. So in this case, there are like 5 clusters running in different location, and once we do this, we know that site will be up here. And next we have to do is we have to create the GSLB service and tell. So I have to be in demo tenant. Yeah, so this particular service you will see here is demo v GSLB, and these are the different. So in this case, DNS is running on every site, so you can or cannot run DNS on each sites. So that's what we have here on the GSLB front, and this will be load balanced based on your algorithm, and you will have the actual local traffic manager being running on those particular VIPs, and the traffic will be handled by them. So that's how a hybrid environment looks like, and that's how you can give your applications running on different clouds, and GSLB can load balance across those traffic. Now, a little bit on the OCVS front, I'll just tell how a OCVS data center look like. So the instance that you see here is a OCVS SDDC, and what we have done is we have this NSX-LB, we have this NSXT instance, and we have this controller up, and the cloud type here will be basically NSXT. If you see this cloud here, the cloud type is NSXT, and what we have actually done is we have given the credentials to this NSXT, and we have given credentials to vCenter. So once it knows this detail, it will just create the instances whenever we need. So first thing we need to do is like bring up the virtual service, and it will bring up service engine, and it will just place the VIPs there. When I say place VIP, it is basically doing the backend routing and whatever is needed to bring that VS up. So in this particular case, we have these tier 1s and tier 2. So I'll just go to tier 1 gateway here. And what it does when we create a VSS, it just creates a static route for particular web. So in this case, there are like one route. And if you see here, this is the web IP, and it tells where exactly it has to go. So the next hop is service engineer, where we have to route the traffic. So that's how the load balancing is done in OCVS environment. So that was pretty much I had from the demo perspective. So I showcased like how GSLB work, how analytics can help you to debug the issues. And post this, I think back to you, Frank. And if there are questions and answers, then we can probably answer the questions here. Are there questions, Frank, on the chat window?
No, so far so good. Let's go ahead and move back to the slide presentation, and I can talk with a couple slides, then we'll go to the questions and answers. I really appreciate that. It's a really great presentation and demo. That was really cool, the things that you showed us. So if you can move to the next slide, please.
Sure.
So overall, I mean, VJ Andrew showed us some really cool things, and he showed us, and we talked about the on-demand scalability. When I say scalability, it's really about that flexibility of the cloud environment and using the load balancing technology to integrate, to create that flexibility for on-demand scaling, for that agility, for that scale in, scale out, active, disaster recovery, all those capabilities. And that again ties into that advanced visibility. I mean, the visibility of that real time that Vijayendra was showing us in that demo is really cool, showing that end-to-end, being able to take just a few clicks to identify, oh, this is a specific server that's running slow. That's crazy. And then to be able to tie that, the ability to tie that into automation tools and scripts to say, okay, I see servers that are reaching this type of thing. I can now tell my system through automation scripts to say, okay, take that server out of service when it's running that slow and bring it back in when it's back happy again. There's a lot of cool things. So that end-to-end automation with this, with that visibility becomes really crucial, as you can see, and really beneficial. And ultimately, that consistency across the environment. So it doesn't matter if you're private cloud, software-defined data center. It doesn't matter if, honestly, if you're using a VMware solution or some other vendors or open source solution. It doesn't matter what cloud you're in, public cloud, private cloud. What we're trying to do is we're creating a platform that really hides and abstracts that layer to give you this uniform, consistent thing of how you want to do things. So it's really, really cool for me in terms of understanding and talking about these next generation, what I like to think of next generation hybrid cloud and multi-cloud environments. So move on to the next slide. I just want to pass this information to y'all as well. There are some resources that I certainly recommend that you look at, and there are resources you can see here, the links, and they're available in the presentation. And is that step-by-step installation instructions on how to do what Vijayendra was showing us in the short demo, a lot more details, number one. And number two, some more information in terms of what the solution means, what it does, how it works, in terms from Oracle, from VMware, as well as we have with VMware within NSX Load Balancer. You can see the avnetworks.com/workshops. There are a lot of online workshops to get more technical, more details, hands-on, to be able to do lots of cool things, and I highly recommend these workshops. They are always been extremely beneficial for the people that have been doing it, and we love doing these workshops for our customers and prospects and everybody out there. So I highly recommend that. So let's go to the questions. And we have a few questions here, and I have time for, I think, a couple questions before we run out of time. So let me see here. Looking at these questions, Vijayendra, this is a good one for you. Are there automation tools available for these migrations? When we talk about these cloud migrations, when you talk about, you know, that lift and shift and all these other pieces, what automation tools do you have that you would recommend?
Yeah. So there have been cases when infrastructure are moving from on-premise to OCVS, and there are a lot of NSX LB customer. They want to use NSX Advanced Load Balancer. So we have migration tool for them, and it can just take the input from the existing load balancer that they're running, and that could be converted into the config objects for NSX ALB, and we can just bring up your SDDC and load balancing instances very quick. So there are tools available. If you try to check, there will be migration tools from other load balancers to move to AVI, or from NSX load balancer to moving to the NSX advanced load balancer. So there are tool availables. There are public GitHub repos where you can find the tools, and there are, of course, professional services are available from VMware that you can utilize, and they can help you migrate.
Awesome. And I have another question here, and this one I think is a great question, is when we talk about these multi-cloud and different clouds, we're talked about Oracle Cloud today, and we mentioned these other ones like AWS and private cloud licensing. So if I think of going back to my old days of using my traditional infrastructure, I had to buy licenses for different components, whether it's hardware or software, for each different environment. How does the license work for bringing this all together from your perspective?
Sure. So this is a good question, Frank, because we have seen customers doing this when they try out new clouds, and they want to know that we are migrating to a particular cloud, or if the same licenses we can use on the cloud. So the answer is yes. So AVI's licensing is basically a centralized licensing, and it doesn't depend on which environment you're running on. As I have said, we are based on the actual utilization of service cores. So each service unit is basically sold based on the how many vCPUs we run. So if you're running on the public cloud and they are using hyper-threading, then for each of those instances, I mean, 2 vCPUs will be equal to 1 service unit, because we do not charge for the hyper-threaded instance. So those sort of things are there, and you can just use those equivalent licenses from on-prem to your public cloud. So that's there. It's a unified license. It's a one key applicable to all cloud type.
That's awesome. That makes things so much easier. I mean, one key across all cloud types, one instance, and just driving everything. It makes sense from the end user perspective, and I know it's I'm sure it's challenging for you and people on the back end to make it work and to make it functional for them. But it is just a huge benefit to make it simple for the end users to be able to implement this. All right, I appreciate this. I think we're out of time, so I'm going to, and if there are any other questions, we will follow up with you offline and definitely answer all your other questions. But everybody, thank you for attending this session. It was really beneficial. I learned lots of interesting things from Vijayendra today, and I'm sure, and hopefully you have too. And we look forward to seeing y'all at the next webinar, next presentation, and hopefully you'll register for more and learn more about us. Thank you very much, everybody.
Thanks everyone for joining.